Okay, now we are started. So I'm Jim Heath. I'm the president of the ISB and a professor here, and it's an absolute pleasure to welcome you all to a day of scientific celebration in honor of our late colleague, Professor Ilya Smilovich. I have some slides. I don't know if they're coming up or not. I wanted to. This is one of my favorite pictures of Ilya because it shows a keen attention to appearance. I think it's the only picture I've seen of Ilya in a tie. And you can see he really stressed about everything. But, Ilya was, in many ways, he was the heart and soul of the ISB. And I want to walk you through some of his career in science. And much of that career is represented by colleagues and fellow collaborators and et cetera, who are here today. And absolutely thank you all for coming. I think of Ilya's career as having proceeded in phases. I think all of us do that. But essentially, Ilya had an insatiable curiosity, and he was an engineer and a physical scientist who was bringing a novel skill set to biology, and it took him a while. So do I have control over the slides here?
Yeah.
Okay. And if you look at Ilya's earliest papers, they actually weren't in biology, they were in music. And I think this was something that I actually resonated with Ilya, because I'm a musician myself. Ilya was actually a phenomenal musician. And I have somewhere here, I have, this is a piece that Philip Glass wrote that Ilya would play. And I'll come back to this in just a second. But when Ilya first began working in biology, he was working on, bringing in Boolean logic. And for those of you who aren't familiar with Boolean logic, that's the and the or and the XOR gates, basically the foundation of binary logic that is computation. And at the time, and this is basically at the turn of this century, biology was sort of slowly going from like the kind of one gene or one protein type of science to an appreciation that with the high throughput tools of biology, many of which were developed by Lee Hood, who will follow me, that biology was becoming an information science, but that one was going to be able to think about biological systems in terms of networks, in terms of basically cooperative systems where the individual machinery components of proteins and genes, et cetera, were working together to form a greater phenomena. And these are some of the earliest works in here. This is about the time that I started thinking about getting into biology myself. I was a physical scientist for much of my career. I had moved to Caltech at around this time, basically to do solid state physics and molecular electronics, just beginning to do a little bit of biology. And so this is a way I thought about biological systems as well, because I had been doing electrical engineering and computer design and things like this. And so I appreciated this way of thinking, but I can guarantee you this way of thinking was not appreciated across the biological world. In fact, it was considered to be radical and novel. But now, if you look at any biological paper out there, people talk about signaling networks. They talk about biological circuitry. This language that was just being formed at this time is now part of the common vernacular in biology. And I put this piece of music in here in the circuit here because I don't have the actual piece that Ilya did. But this is it's a piece of music by Philip Glass that Ilya would play, and he would play it beautifully. And it's probably about 20 pages long. And Ilya, in what looked like an exotic example of this type of graphical approach, condensed it all into one page. And if there's a piece of artwork that I think is a phenomenal juxtaposition of this type of Boolean circuitry, et cetera, coupled with the music that Ilya did, I think it's that one piece of music. I think when he got it, he showed it to, I don't know, some of the major interpreters of Philip Glass, and they were sort of in awe. When I saw it, I was in awe. But this is, I think, illustrative of how Ilya would just look at a problem and out of that complexity, resolve a way to think about the problem and introduce simplicity to it. I think one of the next stages, and this is something that happened when he came here to Caltech, was to play a major role in what's called the Cancer Genome Atlas Project. And this was something that still is part of the ISB. It's in our genes today because we still do a lot of these projects. I'll mention a couple of them in a minute. But this was an attempt, once you started thinking about biological systems as circuits, you quickly realized that the systems themselves were underdetermined. And a way to address that was to actually start establishing large-scale databases to try to at least semi-determine those systems so that one could apply mathematical constructs toward understanding them. And so there's many, many papers that came out of here. We'll hear some of this work today, but this is just one of these papers that came out in probably 2012 or something like that. And it was a really a big hallmark of ISB to have this kind of a project here. You don't think of Ilya as having done translational science, but in fact, the impact of what he did is pretty great. And so I pulled this out because this is we have a clinical trial that we're leading to treat patients with HPV-driven cancers, that's cervical cancers and head and neck cancers. And we're working with 3 places, City of Hope, Seattle, Swedish here, and UCLA to launch this multi-site trial. And this is the package that goes to the FDA when you are asking for guidance on what should be in the full IND that gets submitted. And in this package, there's actually 7 uses of the TCGA atlas to justify clinical decision-making processes that are carried on in this study. This is just one simple example, but of a project that started at roughly, 12 years ago, 15 years ago, to have the impact permeate all through biology, such a big deal, and it's absolutely had a translational impact. And I think those of us in the field almost take it for granted now. But I don't think it was an easy thing to get launched. I was on the scientific advisory board of the National Cancer Institute at the time that they were launching the TCGA, and it was not a simple thing to get rolling. And this type of a project, putting together large data sets, especially in the oncology space, immuno-oncology, imaging, what have you, that allow people to come in and try to determine a problem, try to determine the circuitry behind the biological problem of their choice, is something that continues to be the hallmark of ISB. Here's 2 of these projects that we play a major role in. Here's 2 others. And I hope this is the kind of thing, our commitment to making public data sets and make them available and put interfaces on them so that people can come in and use them easily has been a hallmark of the ISB, and I think it should continue to be one, and it was something that Ilya really drove. And that's a big deal. And now the rest of the world sort of takes this for granted, but it's kind of a big deal. A couple of years ago, Ilya started working in a new area, this concept of digital twins. And 2 years ago, we were trying to put together a big proposal here between UW and Allen and Hutch and us and other places to someone who had a lot of money to fund a big proposal. And I was trying to push, with Ilya's help, this digital twins is a framework for building a big visionary proposal around. And at the time, everyone in UW said, this is too futuristic. No one's going to take this seriously. And within 2 years now, this has almost become a standard way people are thinking about how to use large information content to translate into models for clinical care. And Ilya even used this, and this is just an early example of this, was beginning to use this to try to think about how to develop ways to think about his own disease, AML. And so when I was here, when I came here, I had a natural resonance with Ilya, and I thought, in fact, Ilya was the colleague that I personally felt closest to. I found that most of my colleagues thought Ilya was the colleague that they felt personally closest to, because that was just the nature of Ilya. I wanted to write a grant with Ilya. We wrote a U54, which is a cancer center grant program, to the NCI. Ilya wouldn't take any money from it because we were actually studying, there's like mice involved, and he didn't want to have anything to do with mice. But he helped write the program, and he was there on all the meetings as we began launching the program, and all the meetings as we pushed it forward. And I just showed this because this is the kind of data that Ilya would have loved to have tried to integrate into a model of the whole. So this is a picture of a tumor. Oops. This is a picture of a tumor here. And you can see there's cancer cells, there's immune cells, immune infiltration. This is just a contrast micrograph. And this here, we've taken that one square of the tumor here, and we've measured the epigenome of those cells in that pixel, meaning in every one of these pixel elements, we've done about 50,000 measurements to pull out the structure of the genome, the open chromatin regions that allow you to express and translate genes. And then this is an algorithm that came out of work that Ilya did with collaborators, where you take the H&E image, and just using machine learning and AI tools, you actually can extract out the immune cell content, which actually lines up extremely well with the physical measures of the immune cell content. And so this type of integration of this approach, try to understand how to treat patients with sequential therapies, not combination therapies. In this case, combination therapies don't work, but sequential therapies. Start one for a few days and then put them together when they can be quite effective. I think this is a project that Ilya would have been tremendously excited about. I'm done. You don't have to show me the sign. I'm done. So finally, this is a day of teaching, and Ilya was a great teacher. And in fact, a couple of years ago, I think it was only a year and a half ago, when I was getting excited about this digital twin project, I had Ilya present that to the board. And one of my board members came up to me afterwards and said, your president's presentation to the board was really good, but Ilya's was spectacular. And it was true. Ilya's was actually spectacular. It was awesome. And so thank you all for coming. I'm going to introduce Lee Hood now, Lee Hood was one who actually encouraged Ilya to come to ISB when Ilya was at MD Anderson. And of course, you were colleague and collaborator with Ilya for many years. So, Lee, let me give you the